Welcome back to Garage Time. This week I'm excited to work again on the engine. These are my 912 cylinder heads and I'm attempting a DIY rebuild on these. Now I'm going to take it as far as I can. If I get into trouble or if I find out that I'm not able to hold the tolerances correctly, then I'm going to have to get some help on these. But I thought it's only metal and I should give it a try. Fingers crossed, let's see how we do it.
Garage Time.
The last episode on this rebuild showed me disassembling the heads, inspecting them, and ordering the parts that I needed. Some replacement intake valves. I've discovered a cracked head, so I'm using an alternate head that's not cracked, and I removed the valve guides. Today I'm going to be installing the valve guides, reaming them to the correct valve stem size, and then cutting the seats so we get a good seal between the valve and the head. Okay, the first step today is to clean up these bores where the valve guides go. I ran this ball hone down in the bores just to clean up some of the scratches that were left in the bore when you extract the valve guides. That can interfere with the measurement a little bit. So this is a fine grit, doesn't remove much material. It just creates a smooth surface to really get an accurate measurement on the bore size. I also went inside these bores with compressed air and a toothbrush to make sure there's no grit or anything in there to affect the measurement. This interference fit is really important so the valve guides will stay put under all temperatures and conditions. So at the bottom of this bore, for some reason, it is slightly bigger than the top. So I'm capturing that here with my notes. So that's about 1/2 thousandths of taper in the bore. So I'm taking that into account when I size the valve guide. Just want to try to get the best valve guide position for each of the bores. 0.5561. Okay, I don't want to bore you guys too much with the numbers, but this is the notes from the top of the bore to the bottom of the bore and kind of the shape of the head. The valve guide dimension is here. Now I ordered the valve guides a little bit big, so I wanted to size them correctly to the bore. So I can always remove material, but I can't add it. 400 grit paper on this flat surface. Really consistent readings, so I'm not really messing up the diameter, just making it smaller. I need to get to 0.5549, so I got to keep going. These are just sitting in here at the moment, but they've all been sized correctly. 0.02 of an inch interference fit. Okay, I spent probably 30-35 minutes resizing all 4 of the valve guides with sandpaper, and I was able to get consistent readings along the length. One thing that did happen though is the guides would heat up just ever so slightly, and that affects the measurement actually. All these measurements are supposed to be done at room temperature, and when you put a little bit of heat into them and you can feel it in your hand, it affects the reading. So I had to cycle between each of the 4 guides and let them cool down, get the final reading. So that's a great segue into the next piece because I'm going to be using temperature to my advantage. I'm just waiting for my head to heat up in the barbecue. I'm gonna try to get it to like 300, 250, 300 in there. It shouldn't damage anything. And then inside here are The valve guides, they've been frozen for quite a while. This is number 4. I've got them labeled according to the bore size. Well, here we go. DIY valve guide replacement. Take 1. It's always the last one you get. Okay, number 3. I know where that goes. It's like a little bit of fire and ice. There she goes down the hole. Starting to generate some pressure. Now there's a ridge on there that I'm watching. I don't want to over push it in. Get my flashlight. Yeah, right there. It's fully seated. It just wants to go in. You can see a little bit of push marks on the valve guides, and it's nice and uniform, no streaking or galling or anything. So I call this a success. No damage to the top of the valve guides either. Now I'm going to go put this back in the barbecue because it's better if it cools down very slowly as opposed to just shocking it here without anything attached to it like an engine. Okay, I had to make a few changes here to do the exhaust valve guides. These are the ramps I used for the drilling fixture. And then I also had to change out the big jack for a much smaller jack. This one is shorter, so I'm able to get the actual height here to do the pressing. This jack over here was way too tall. I don't need 20 tons. This is much less than that. Sorry about that. I think I lost you guys when I was pushing in the exhaust valve guides. I ran outside and the memory card was full, so I apologize. The exhaust guides went in pretty similar to the intake guides. It was just a little bit more noisy. I think there was a little bit more compliance or flexibility in this wedge structure, and these plates were sort of chattering a little bit, so it kind of went clunk, clunk, clunk when it went in. So now that the valve guides are in the heads, now becomes the fun part of sizing the internal bore so that the valve stem to valve guide clearance is perfect. I guess the first thing to try is just put the valves in. So this is a brand new intake valve. Just putting some light oil on it. And yeah, it won't even go in very far. Yeah, 0.39220. So that's exactly 1/1000th of an inch too small, and it needs to be the other way around. It needs to be about 1 to 1.5 thousandths too big. So I got to remove some material from the inside. I have a finish reamer, a solid reamer that's a piloted reamer for valve guides, and it should be here tomorrow. But I don't want to do it all in one shot because it's just going to grab the valve guide. This is very grabby material, so you don't want to take off like 1.5 thousandths per pass. It's a little bit too much for that reamer, and you won't get a great finish. It could catch because it's a hand reamer and there's no spindle to control its position. So you want to sneak up on it. So the first thing to do is to make the hole slightly bigger, and I have this adjustable reamer. And these are, like I said, adjustable, but they're not that great. They're not a finish reamer. They're not what you need for the final size. It's a little cutting oil on there. Now the problem with these reamers is that there's no pilot on it, which means it's hard to get it started in the hole. So what I like to do on these is loosen it up to the point where it'll actually go in. So just a little bit of drag on that. I'm going to loosen it up a little bit more. 1/8 of a turn. And these don't need to be really tight. So it's going in, and you can feel right where it goes into the head itself. That's where the guide has gotten smaller due to the interference fit, and that's where it starts to fit really tight. Right about there. So now it's centered in the bore. So we just rotate it and hopefully not take off too much material. It's the lightest of cuts. Okay, now it's gone all the way through. So it did remove a tiny bit of material. So we'll measure and see how we did. Cleans that bore out just a tiny bit. 2 10,000ths of an inch. So we're dealing with really small numbers, you guys. So I'm gonna do 1/8 of a turn tighter. And go again. Okay, I've done about 8 passes on just this one guide alone, each time taking off like just a 10,000ths of an inch at a time. So I finally got the valve to actually go in, but it's very snug, which is still too tight. But I'm sneaking up on it and getting it really close. This valve fits perfect. It's too tight, but it feels really nice here. I'm just cleaning up this exhaust valve. This is a used valve that measures okay. So I'm only cleaning up this portion here that had a little bit of rust on it and some carbon buildup on it. I'm not touching the stem at all with this Scotch-Brite pad. Okay, this is the reamer that just arrived. This is used, although it came from someone who I trust. And this is the 10mm reamer with a pilot. So you can see this is a little smaller diameter pilot. That's there to make sure it goes in straight, and then it starts cutting in this area right here. Okay, there we go, there's a handle. I'm just gonna put a little bit of this cutting fluid on there. Be very careful. Feel it going nice and straight. Starting to just do a little bit of cutting right now. Let's just clean up this hole. And then we'll check it with the actual valve. And it's perfect. Like, I'll do the measurements, but the feeling of this is just so nice. It's just gliding perfectly with no wiggle. You can see it's kind of scraping the oil off just ever so slightly, which is why the clearance is so important. You don't want it to scrape all the oil off, otherwise it'll seize. I have 3 tools for checking. One is this tapered gauge because it is exactly 10mm at the end. I also have this ball gauge, which is really useful in measuring the center of the guide and also if there's any taper in there. So you loosen it until it just has some resistance, and then you can slide it up and down and you can feel where it's tight or where it's loose. When this goes in, it stops. And it's designed to stop. And you can see it stops right about there. Okay, when I do the measurement with the ball gauge, which is probably a better indication of the overall diameter, I'm getting a clearance of 1/1000th of an inch, which is slightly too small. It should be a 1.5 thousandths clearance. So I'm going to run the hone through just really quickly and try to, create the crosshatch in there, but also open it up just a few more 10/1000ths of an inch. Okay, that just took off 4 10/1000ths. And I barely pushed it in there, so that might be perfect. It is 0.0015 of an inch. The workshop manual says you can go all the way up to 2.2 thousandths. Okay, it's noticeably looser now. It's really going in really easily. Okay, now I'm doing the same treatment to the exhaust. Porsche specifies a 3-angle valve seat geometry. It's a 45-degree angle where the valve actually seals against the valve seat. There's a 15-degree angle on top of that, and then a 70 or 75-degree angle below that as it goes down into the runner. So to cut those angles, I'm using these New Way cutters, this kind of a UFO shaped thing, and it's got multiple carbide cutters that revolve around a pilot. Now the pilot is fixed. It goes inside the valve guide and it's a rigid pilot, doesn't move. It's called a dead pilot. I'll link to the New Way cutters in the description below. Okay, some of these cutters are new and some of them I've had a while. This one's a new one. And it's a 75-degree on this side and it's a 15-degree on that side. So this one should come in really handy, although there is a problem of interference with the valve guide. Let me show you. This is the pilot system I was just talking about, and this cutter is designed at a precision fit to go right through here. It's got a little bit of oil on there. This is a sliding surface. This side goes into the valve guide, and this is a tapered portion. So what happens is it fits in loose to begin with, and then as it goes in, it gets tighter and tighter, and then you just rotate it till it's really tight. Now, this is a fixed pivot. So the idea is that when this spins, it's going to cut the seats concentric with the valve guide. The issue that I'm having, though, is, and I've already thought about this before I put the valve guides in, this portion of the cutter on the bottom, this can cut, from top or bottom. That's why there's 2 different drive sockets on here. The problem I'm having is that before the cutters make contact with the intake valve, it actually touches the valve guide here inside the hole. So if you look there, there's the valve guide poking through. So when this comes in, it won't go deep enough because of the shape of the body of this. It won't go deep enough. I have to confess, this video was recorded out of order. I've actually already cut the 75-degree seats in the valve guides. Let me show you how I did it. I ended up using a temporary valve guide. Okay, I know that contraption looks a little wonky, and let me explain the whole setup. So normally these cutters, they have a hex drive on the back and they're turned with a T-handle. This is my T-handle, and you can turn it by hand. Let me set that down so I don't drop it. This is a kind of a fancy T-handle. It has a housing around it, so the housing is fixed and the center spins. So this happens to have, I made this, it's got a ball bearing in it, and there's a socket on the end. And it allows me to put pressure on with one hand and spin with my other hand. Now the issue with spinning these by hand is that every time you start and stop to get a new grip on it with your wrist, you leave a little, potentially you leave a little mark on the valve seat. And so you got to clear it each time you go around, and all the start and stops can create some unevenness on the valve seat, which if you have a good technique and you're patient, you can get through it. The better way is to use a motor to drive the handle. So this contraption, my drill press, it's not doing any of the alignment. It's only driving the handle for me. And that's the part that looks a little wonky. And then you're probably saying, well, like, how did you get your drill press to spin that slow? I'm not really proud of this part, but I'm gonna show it to you anyways. When there's a will, there's a way. I have this old transformer, which I thought would be enough to control the speed of the motor to get the RPMs as low as I wanted. But what happened was it didn't go slow enough. Here's how it looks now. I can speed it up or slow it way down. It'll go pretty slow. But that's after I had to convert the motor to something new. Okay, just like any drill press, you normally adjust the speed by moving the belt up and down the pulleys. Well, back here, this pulley was spinning too fast, even with the transformer. So I sort of just attached, I don't know what you want to call this, but I strapped my drill motor to the side of the original motor, and it's blocked, and the thing is in its on position. So when I turn this on, it looks like this. There's a couple washers driving the original belt, and it just turns the bigger pulley to a slower speed. And then I'll typically run this here on the floor so I can just use my foot. This is spring loaded, and this portion of the handle has a pilot hole as well. So these two go together. Now you can see if I move my hand, the drill press has nothing to do with the positioning of the valve cutter. It only provides the rotation. As a quick reminder, this video is part 3 in a series of my 912 engine rebuild, so I'm going to link right here. So we're using some Dychem or Prussian blue, whatever you want to call it, on the actual seat so we can see that we're cutting all the way around. Then we'll check the position of the seat relative to the valve. Starting really slow here. Okay, I'm really happy with how this 45 degree came out. I don't see any sort of marks or chatter or anything wrong. The surface finish looks really nice. So I'm going to move the pilot over to the exhaust now and try to cut that thing. So I'll have to put this head on its wedge again to get the angle correct. Here's a great shot of the concentricity. So you can see a nice heavy cut on this side, and then over on this side, it's barely touching at all. So I just got started on this one, and you can see the blue is left behind. And then we'll tune up the width of the seat with the other cutters, which is the 15 degree and the 75 degree. That's how we tune up the width of the track, but right now it needs a lot more work. I just want to check the position of the seat relative to the valve stem. So I'm marking the valves with more of this blue stuff, or a pen, either one. Okay, so now you can see where it's making contact, and it's starting to make good contact all the way around, but the seat is pretty close to the valve edge. It's a small little mark right there left. It's almost easier to see it with pen. One of the things in the workshop manual I thought was funny is they tell you, to test and see if your valve is leaking, and then it says put gas in there and see if it leaks out. So I thought I would give it a try, but instead of using gas, I'm just going to use some Windex. So I'm just, with a little bit of finger pressure, or I'm just kind of holding the valve with my hand, and fill it up with Windex and see if it leaks. I'm just going to hold it over the paper for a few minutes, for a little while. You can kind of see the Windex in there sloshing around. But it doesn't seem to be leaking out. Cool. So cutting these valve angles is a very iterative process, and it is critical to get good flow in the head. The 45-degree angle is the one that creates the seal, and the other angles are the ones that create the flow around the valve seat, and it's really important. So I'm going to spend a little more time iterating back and forth. Also, I can't do much more on the exhaust valve. I need to have that valve reground on its perimeter so I can find out where the seat is contacting the perimeter. So once that gets finished, I'll be able to do that. I wanted to get more done on the heads this week, but of course I'm out of time. So check back next week. Hopefully I'll have the exhaust valves reground and I'm able to just get through this. Today was more about proving the process, and that little test with the Windex seems to be good, that I'm on the right track. I'm going to develop a better pressure test next week using compressed air, and I'm also going to be hand lapping the valves, and so I'm going to keep iterating until these valves are sealing really good. I'm really confident on the valve guide installation and the valve guide clearances, so now we just have to work on the valve seat seal, and we should be good to go on the heads. Thanks for watching. See you next week.